Hello dear students, welcome in our video lecture of Redox reaction. That is the 8th chapter of our standard 11. This is our third lecture on Redox reaction, and now in this video we are going to learn about what is oxidation number and what are the rules to find out the oxidation number of any element in a compound. So this topic is a larger topic, and we should have to make at least 2 or 3 videos on this. So in this video we are going to see only some rules with the help of which we can find out the oxidation number of an element. Okay, so let us start. Take your pen and notebook with you, and let us start. What is the oxidation number means? So here I have written a definition of oxidation. There is no need to memorize this definition, but you have to understand what this definition says to us. Okay, now let us start. Oxidation number means it denotes the oxidation state of an element in a compound ascertained according to a set of rules that we are going to learn today. Ascertained to a set of rules formulated on the basis that electron in a covalent bond belongs entirely to more electronegative element. Now let us try to understand this definition. We know that in periodic table the elements which are situated to the right side, that means nitrogen, oxygen, chlorine, bromine, iodine, sulfur and phosphorus, these are the electronegative elements, and the elements which are situated on the left, that means most of the metals, are electropositive elements. Now this definition says that if there is a covalent bond between hydrogen and chlorine, this cross represents the electron of hydrogen and this dot represents the electron of chlorine, and they are having a pair of electrons which is shared between them. So this represents a covalent bond between hydrogen and chlorine. Now we know that chlorine is the electronegative element and it is attached covalently with hydrogen. So according to the definition, electron in covalent bond belongs entirely to more electronegative element. Now, this electron was of chlorine, but this was of hydrogen. But according to the definition, chlorine being more electronegative, it pulls both these electrons towards itself. So, this pair of electron is attracted towards chlorine. And if it happens, then we have to consider this chlorine as having a -1 charge. Why? Because it is pulling one electron of hydrogen which is in the covalent bond. So electron is having a negative charge, and if this negatively charged electron is pulled by chlorine, then chlorine will have -1 charge. And if this hydrogen, this electron which was of hydrogen, is pulled by chlorine, that means one electron from hydrogen is some kind of gone or lost. So in that condition, the negative charged electron, if it is lost by hydrogen, then this hydrogen will have a +1 charge because one electron is pulled by chlorine. Therefore, chlorine will have -1 and hydrogen will become +1 charged species. Now, these charges are considered as the oxidation number according to this definition. And if somebody says, what is the oxidation state of chlorine in HCl? So now you can see it is -1. And what is the oxidation state of hydrogen in HCl? Then you can say it is +1. So when you speak the oxidation number, then you have to indicate whether this value is positive or negative. Oxidation numbers are written always except 0. Oxidation numbers are written always with positive or negative sign except 0. If there is 0 oxidation number, then there is no need to write any positive or negative sign. But if oxidation number is a figure other than 0, then you have to indicate its sign, whether it is positive or negative. So this is the simplest information about what the oxidation number is. Still, we are going to learn deeply about the oxidation number. There will be 3 lectures, as I told you, on oxidation number. So this is our very first lecture and we are in initial stage. So if it looks like a little difficult, then not to worry. You will definitely understand what is the oxidation number with confidence. Okay, so this is an example which I have given you to understand this definition. If 2 elements are attached with covalent bond, then the electrons which are in covalent bond are entirely associated with more electronegative element, and if it happens, then electronegative element will get negative charge and electropositive element will get positive charge. But there are so many rules. This is the simplest example, but now we are going to learn some rules with the help of which we can find the oxidation state or oxidation number of any element. Okay, so let us start. First of all, pause the video and just write down this definition. Again, there is no need to memorize or mug this definition. You have to understand the concept of the definition. Okay. And let me clear one thing to you. There are 2 words. Sometimes in high school level, oxidation number and valency are considered as synonymous, but they are not. There is a vast difference between these groups. Oxidation number and valency are not synonymous words. Okay. Now let us clear it first. Oxidation number and valency. Now valency means the total number of electron required to complete octet, or you can say that the total number of electrons which are accepted or donated or shared by an element to complete its octet. That is known as valency. Now, if you consider an example of sodium, then according to our high school, its electronic configuration 11 is the atomic number of sodium, and its electronic configuration is in first orbit there are 2 electrons, in second orbit there are 8, and now only 1 electron is left, so it will be in third orbit. So this is the electronic configuration of sodium. Now, if sodium wants to acquire the completely filled electronic configuration, then the easiest way is to donate this electron to some other species. And if it happens, then it will have the completely filled electronic orbitals. So in that case, sodium is willing to donate 1 electron. So the valency of sodium will be 1. Valency of sodium is considered as 1. Now there is no need to write plus or minus sign when you are talking about valency. As far as oxidation number is concerned, you have to write positive or negative sign. But as far as valency is concerned, there is no need to write positive or negative sign. Valency is only a number without any sign. Okay, now let us consider the electronic configuration of chlorine. Chlorine having atomic number 17, its electronic configuration is 2, 8 and 7. Now to complete its octet, only 1 electron is required. So if somebody donates 1 electron to chlorine, then chlorine will have complete octet electronic configuration. So in that condition, what will be the valency of chlorine? Again, our answer will be 1. There is no need to write negative or positive sign. valencies are only numbers without any sign. So valency of sodium is 1, valency of chlorine is 1, not plus 1 or minus 1, only 1. So valency means, okay, one more example. Let us consider the electronic configuration of carbon, electronic number 6. First orbit contains 2 electrons and the second contains 4. So to complete the octet, carbon requires 4 electrons. Now it is not possible for carbon to have 4 electrons, or no element is able to donate 4 electrons to carbon. So in that condition, carbon will share its 4 electrons to some other elements. So sharing will occur. Sharing of 4 electrons. So if 4 electrons are shared, then carbon will have complete octet. In that manner, its valency will be 4. Again, there is no need to write plus or minus sign. So here, for carbon, valency is 4. For chlorine, valency is 1. For sodium, valency is 1. Now let us come to the oxidation number. If somebody says, what is the oxidation number of sodium? Then our answer will be 0. Because here, oxidation number means electron in a covalent bond belongs entirely to more electronegative element. Now here, we have sodium alone. It is not attached with any element. So there is no need to discuss about the sharing or more electronegative or less electronegative element. So it is sodium alone. There is no sharing, there is no donation or sharing of electron with other element. In that condition, if sodium is alone or if any element is alone, its oxidation number is considered as 0. So all elements, if they are in free form, not attached with any other elements, then oxidation number is considered always as 0. Valency of this sodium is 1, but now its oxidation number is 0. But when sodium is attached with any other element, in that condition its oxidation number will have something. Suppose if we consider NaCl, now electron in a covalent bond, though here this is an ionic bond, but still according to definition we have to consider it as a covalent bond, because in chemistry you will learn no bond is completely ionic or completely covalent. So here, suppose sodium and chlorine are having a covalent bond, and as we know chlorine is more electronegative than sodium metal, so it will pull the pair of electron. That means chlorine will have negative 1 charge, sodium will have positive 1 charge. So now in NaCl, if somebody asks what is the oxidation number of sodium, then your answer will be plus. But if sodium alone, then the oxidation number will be 0. So this is the difference between oxidation number and valency. If somebody says you that what is the oxidation number of X element, now as it is an element alone, its oxidation number is always. But when that same element is in any compound, then you have to calculate the oxidation number by using some rules which we are going to learn today. Okay, so this is the simplest difference between oxidation number and valency. Now from today, there will be no confusion between oxidation number and valency. Valency is the total number of electrons which are shared or donated or accepted by an element to complete its octet. While the oxidation number is a totally different thing, and about which we are going to learn from today. Okay. So pause the video and note down these points. Okay, now let us learn the rules to find out the oxidation number. So there are so many rules, and in this video we are going to make a list of some basic rules. And after writing these rules, it is not said that when you know all the rules to find out oxidation number, you will be able to find the oxidation number of any species. It is not necessary. You have to do practices, lots of practice. Then after you will have a confidence. Then I can find the oxidation number of any species in any. Okay, now let us start. The very first rule, rules to find out the oxidation number. Title બનાવીને અને આપણે શરૂ કરીએ. First rule, the oxidation number of any free element is always 0. If sodium is alone, its oxidation number is 0. If carbon is alone, its oxidation number is 0. Any element, free element, which is not combined with any other element, then its oxidation number is considered as 0. Oxidation number, second rule, oxidation number of any molecule, the total oxidation number of any molecule is always considered as 0. So if you consider H2O, now H2O is a molecule and the total oxidation number of H2O will be 0. If somebody says NaCl and the total oxidation number of NaCl will be 0. Each molecule is electrically neutral. There will be no charge in any neutral molecule. So the total oxidation number of that molecule will always have a value equal to 0. Okay, now third point. Any charged species is having total oxidation number equal to its charge. Now if we want to write any examples, then if somebody says Cl minus 1, now this is a charged species, so its oxidation number will be minus 1. If somebody says Al plus 3, then its oxidation number will be plus 3. If somebody says SO4 minus 2, this is a charged species having multiple atoms, so its total oxidation number will be equal to its charge, that is minus 2. And if somebody says NH4 plus, then the total oxidation number will be plus 1. Just try to understand carefully. Any charged species is having total oxidation number. Total oxidation number will be equal to its charge. So here this charged species is having charge -2, so its total oxidation number will be -2. Okay. Now fourth. Now it is very important. Hydrogen can have +1 or -1 oxidation state in different conditions. Now if hydrogen is with electronegative element, then its oxidation number will be +1. But if hydrogen is with electropositive element, then its oxidation number will be -1. Now you know very well what is electronegative and what is electropositive. Electronegative means the element situated on the right side on the periodic table, while electropositive are metals situated on the left on the periodic table. So if hydrogen is attached with nitrogen, fluorine, chlorine, bromine, oxygen, iodine, then hydrogen is having +1 oxidation state. So in HCl, the oxidation state of hydrogen is +1. If you say in H2O, the oxidation state of hydrogen is plus because it is attached with electronegative non-metals. But if hydrogen is attached with sodium, NaH, then this hydrogen is having oxidation number -1. If you consider hydrogen with magnesium, MgH2, then the same hydrogen is having oxidation number -1. So, if hydrogen is attached with metal, its oxidation number is considered as -1, and if it is attached with non-metal, then its oxidation number is considered as +1. Okay, now one more important thing. Oxygen can have different oxidation numbers. In simple oxide, the oxidation number of oxygen is equal to -2. In peroxide, the oxidation number of oxygen will be -, and in superoxide, the oxidation number of oxygen will be -1/2. So now let us take some example. If we consider H2O, this is the simple oxide. So in such kind of oxides, most of the compound of oxygens are simple oxides. Most of the compounds are simple oxides. That means in most of the compounds, the oxidation state of oxygen will be negative. But when you write H2O2, now here this is hydrogen peroxide, and in peroxide each oxygen is having oxidation number as -1. Here these two oxygen will have the total oxidation number -2, while in H2O only one oxygen is having oxidation number -2. So in peroxide oxygen is in -1 oxidation state. But when you say superoxide, suppose NaO2. Now here the oxidation state of oxygen is -1/2. So these are the different compounds: H2O, simple oxide, H2O2, peroxide, and NaO2, that is superoxide. એના વિશે આપણે પાછું ડિટેલમાં પણ ભણશું. અત્યારે ખાલી રૂલ આપે છે. Okay, now oxygen can have, now let me write, oxygen can have +2 oxidation number when it is attached with fluorine. So if oxygen is having compound with fluorine, then oxygen will be in +2 oxidation state. So oxygen can have plus as well as minus oxidation state in different compounds. When oxygen is attached with fluorine, its oxidation number will be +2. Suppose OF2. In OF2 compound, the oxidation state of oxygen is +2. કઈ રીતે હમણાં આપણે થોડીક વારમાં જ ખબર પડશે. હું અહીંયા જી પોઈન્ટ લખી દઉં છું. 6. Fluorine is always having oxidation number equal to -1 in all its compound. Fluorine is the only element which is having -1 oxidation state in all its compound. ક્યાંય પણ ફ્લોરિન નું કમ્પાઉન્ડ હોય, ફ્લોરિન નો ઓક્સિડેશન સ્ટેટ ને -1 જ કન્સિડર કરવાનું. બાળકો એકદમ શુદ્ધ ગુજરાતીમાં બોલી દઉં. આ જે કઈ રૂલ્સ છે ને એ અત્યારે આ લેક્ચરમાં તમે ખાલી રૂલ્સ ને સમજવાની ટ્રાય કરજો. સમજાશે નહીં પૂરેપૂરું કે ખરેખર ચાલે છે શું. પણ જેમ આપણે આના પછીના વિડીયોની અંદર આના એક્ઝામ્પલ લેવાનું શરૂ કરશું અને એમાં પાછા આપણે રૂલ ને એપ્લાય કરશું ત્યારે તમને ખબર પડશે. વાહન ચલાવવાનું મેન્યુઅલ ખાલી વાંચી લેવાથી વાહન ન આવડી જાય. હા, મેન્યુઅલમાં લખેલું યાદ રહીએ ખાલી, બાકી વાહન ચલાવીએ અને મેન્યુઅલના નિયમને એપ્લાય કરતા જઈએ તો વધુ આપણને જાણવા મળે. સેમ વસ્તુ અહીંયા પણ લાગુ પડશે બાળકો. નિયમો ખાલી અત્યારે તો લિસ્ટ બનાવીએ છીએ એમ સમજો ને. નેક્સ્ટ વિડીયોમાં આપણે આ નિયમોનો ઉપયોગ કરશું અને ત્યારે આપણને ખરેખર આ સમજાશે. Chlorine is always in -1 oxidation state. And the last rule for today, this is not the last rule, this is last rule for today only. The last rule is chlorine can have -1, +1, +3, +5 and +7 oxidation number in its different compounds. The same element can have a variety of oxidation states in its compound. હવે ક્યાં એ પણ આપણે ડિસ્કસ કરવાના છીએ એના પછીના લેક્ચર. વિડિયો ઘણો લાંબો થઈ શકે એમ હતો, આપણે એવું કરવું નથી એટલે આપણે આ વિડિયોમાં માત્ર રૂલ્સ શીખ્યા. આના પછીના વિડિયોની અંદર આપણે ઓક્સિડેશન નંબરના રૂલ્સને એપ્લાય કરી જુદા જુદા એલિમેન્ટના ઓક્સિડેશન નંબરને કાઉન્ટ કરતા શીખશું. એ વધારે ઇમ્પોર્ટન્ટ રહેશે, પણ એના માટે આ વિડિયો અને આનો રૂલ જે મેં બોર્ડ ઉપર લખેલા છે અત્યારે, આ 7 રૂલને તમે વિડિયો પોઝ કરી તમારી નોટ લખી લો. પછી આનો ઉપયોગ કરતા શીખશું ત્યારે તમને આનું ઇમ્પોર્ટન્સ સમજાશે. So that's all for today's video. If you like the video, then press the like button. Share this video among your friends, and if you are new to this channel, then subscribe our channel. Press the bell icon. So till we meet next time.